Betelgeuse, the enormous red supergiant closest to Earth, has shown a remarkable decline in brightness in recent years, sparking a wide range of reactions worldwide. Some theories suggest this fading might signal the approach of a supernova, a catastrophic explosion that raises concern among scientists and the general public alike. Betelgeuse, a major star in the Orion constellation, has regained some of its former brilliance after dimming. Yet, it seems to be entering a phase of reduced activity. Experts are now pondering the future of Betelgeuse and whether its eventual detonation could have any impact on Earth. Orion, one of the most iconic constellations in the sky, is well known for its two primary stars, Rigel and Betelgeuse. The latter, also referred to as Alpha Orionis, is the largest and most luminous star in Orion. Observations made by NASA's Hubble Space Telescope and various other observatories revealed that Betelgeuse underwent an extraordinary mass ejection in 2019, an occurrence never recorded in any star of its kind. Although coronal mass ejections, CMEs, are relatively common with our Sun, this particular outburst from Betelgeuse is unique and has generated significant intrigue among astronomers. This massive burst of mass, expelled by the star, was 400 billion times greater than the typical CME observed in stars like ours, briefly obscuring some of its light and leading to its unusual dimming. Estimates regarding the distance of Betelgeuse from Earth vary, with some placing it as far as 724 light-years away. Measuring the distance to red supergiants such as Betelgeuse is challenging due to their vast size and unusual traits. Betelgeuse is one of the most luminous stars visible from Earth, shining with about 100,000 times the brightness of our Sun. However, such intense luminosity comes at a cost. Betelgeuse is expending its energy rapidly, burning through its fuel, and speeding up its inevitable demise. The star will eventually exhaust its fuel supply, collapsing under its own gravity and potentially triggering a supernova, a violent explosion that might eventually leave behind either a neutron star or a black hole, assuming current scientific theories hold. Does Betelgeuse pose a danger to Earth? If the star were to explode in a supernova, its outburst could have catastrophic consequences for Earth. Supernovae are capable of emitting light so bright that it can rival an entire galaxy. Even if Betelgeuse is relatively distant, such an explosion would be hard to ignore. Since the last supernova observed in our galaxy was in 1604 and the most recent one in 1987 occurred in the Large Magellanic Cloud, 169,000 light-years away, the destructive potential of a nearby supernova remains an intriguing yet concerning possibility. If such an event were to unfold within our galaxy, it could have profound implications for Earth. Supernovae, though spectacular, are much less powerful than gamma-ray bursts, which are on an entirely different scale. While supernovae have the potential to obliterate biospheres and blanket planets in deadly radiation, it is their ability to strip away a planet's ozone layer that is particularly troubling. A weakened or destroyed ozone layer exposes the planet to harmful ultraviolet radiation, which could result in an extinction event. The initial radiation burst from a supernova is dangerous, but the more insidious threat comes in the form of cosmic rays that arrive hundreds of thousands of years later, capable of further damaging the planet's surface and potentially preventing life from recovering. Historical evidence of supernovae. Historical records show evidence of past supernovae. For example, traces of iron-60, a radioactive isotope formed during supernova explosions, have been detected in Earth's oceans and lunar regolith, suggesting that Earth may have been affected by a supernova within the past few million years. Although astronomers have ruled out any imminent supernova threats, they have discovered another potential risk. Certain types of supernovae emit radiation that can travel vast distances and inflict damage on planets like Earth. When a star nearing the end of its life is surrounded by a substantial amount of material, a specific type of supernova may occur. The shock wave from the initial explosion strikes the surrounding disk, triggering the emission of vast amounts of X-ray radiation. This high-energy radiation has the potential to deplete a planet's ozone layer by as much as 50%, which could induce an extinction event within a range of 150 light-years. Fortunately, no such X-ray supernovae are currently known to be near enough to Earth to pose a direct threat. These findings have caused astronomers to reconsider the boundaries of the galactic habitable zone, the region within galaxies where life is likely to exist. Star formation in the outer regions of a galaxy is too low to create the necessary elements for rocky planets, while the inner regions, where stars are born and die quickly, are hazardous due to frequent supernovae radiating the surrounding areas. This research suggests that the boundary of the galactic habitable zone may be farther from the galactic center than previously thought. How would Betelgeuse's supernova appear from Earth? While the biosphere on Earth would likely remain intact, the spectacle would certainly be impossible to miss. According to astronomers Goldberg and Bauer, Betelgeuse's explosion would result in a luminosity roughly half that of the full moon, visible for several months. This brightness would be visible even during the daytime and cast shadows during the night. For several years after the explosion, the supernova's remnants would continue to be visible to the naked eye. Although Betelgeuse's supernova would be a fascinating event, it would not be without consequences. The global fascination with such a phenomenon would be undeniable, but the long-term implications for Earth's environment remain uncertain. As scientists continue to monitor this red supergiant, we can only wait and watch, hoping that the threat, if any, is far off. The outcome of Betelgeuse's eventual supernova explosion would be a stunning sight, but not without significant consequences. The enormous burst of light from such an event would likely be the second brightest object in our sky, right after the sun. During its peak, it would shine with an intensity so great that it could easily outshine the moon. This would cause the star to become visible during daylight hours, casting visible shadows in the darkest of nights. The sheer brilliance would captivate observers worldwide.